Yeah, welcome back to our chemistry class. Today we are going to be dealing with balancing of redox reaction in acidic medium. The following rules are applicable in balancing redox reaction in acidic medium. Before we proceed, if you are a new member on this channel, kindly subscribe and click the notification bell for our subsequent contents. Number 1, write down the half equations to show the species reduced or oxidized and products formed. 2. Balance all atoms except oxygen on the left and right hand sides of the half equations. Rule number 3. Determine the difference in the number of oxygen atoms present in the left and right side of the half equations represent the difference in oxygen atom as being present in water on the side with minimum oxygen. The necessary hydrogen for this water can be considered as being present as hydrogen ions on the other side. Number 4, balance with respect to charges by the addition of the appropriate number of electrons. 5, balance the half equations so that the number of electrons lost equals the number of electrons gained. Rule 6, add the half equations together, cancelling where appropriate. Rule MB notes, if there is no difference in the number of oxygen atoms on both the left and right hand sides of the half equations, then proceed to Rule 4. Don't forget to subscribe to our channel and like and share to other members. Thank you. You're welcome back to the second part of our topic, balancing of redox reaction in acidic medium. We have took ourselves through the rules in balancing redox reaction in acidic medium. Let us now move on to the practical aspect of it, how to balance it in reality. Just before we venture into this, if you have not subscribed to my channel, kindly do so and click the notification bell for my subsequent contents. And don't forget to share, like, and comment as we move on this topic. So let's drive on. Example 1. Balance the following redox reaction in acidic medium. Now I want to balance this redox reaction in acidic medium. The first rule is for us to look for the oxidation states of each of the atom that changes except oxygen, meaning that we are going to separate them into oxidation and reduction using the oxidation number. Fine. The oxidation number of carbon in this, if you could recall, or if you are a new member here, you can kindly look at this description below to look at the link needed to look for how to balance, how to get the oxidation number of elements. But let's quickly do a recap. To get the oxidation number of carbon here, we have C2O42 minus. The oxidation number of carbon here is unknown. We have X, then multiplied by these 2. Then plus, oxidation number of oxygen is minus 2. Minus 2 multiplied by 4. Oxygen owns this 4. Then raised to power this power, which is what? Minus 2. S times 2 we have 2x. Plus times minus we have minus. 2 times 4 we have 8 equals to minus 2. Here we have 2s is equals to, this goes here, minus 2 plus 8. 2x is equals to minus 2 plus 8 we have plus 6. Divide both sides by these 2 to get our value of x. S equals to plus 3. Now, the oxidation number of carbon here is plus 3. Now, move on to manganese in this place. Mn O4 minus. Manganese is unknown, X, plus oxygen minus 2 multiplied by 4 in bracket equals to the power here, which is minus 1. Then X plus and minus, we have minus 2 times 4, we have 8 equals to minus 1. Take this one here. S is equals to minus 1 plus 8. S equals to plus 7. So here, the oxidation number of manganese here is plus 7. Now, the oxidation number of manganese here is going to equal to the charge on it. And the charge on it is +2. So we have +2. Then carbon here, CO2. Carbon is unknown, X plus oxidation number of oxygen is -2 multiplied by these two. Now if you look at this, there's no power here. The sum of the oxidation number of a compound will equals to 0. So this equals to 0. So we have X plus and minus minus 4 equals to 0. Take this here. S equals to +4. So carbon here is +4. Fine. We are able to get the oxidation number of each of the elements that changes except oxygen. Now, let us now look at this. We have carbon here. This carbon is moving from +3 to +4. You can see that it's increasing in number. The oxidation number is increasing. When the oxidation number increases, that is what we call oxidation. So oxidation is defined as the increase in oxidation number, while reduction is defined as the decrease in oxidation number. So from here, we can have C2O42 minus moving to CO2. We call it oxidation. While plus this manganese is moving from +7 to +2. That one is reducing. MnO4 minus moving to Mn2 plus. This is reduction. So that's the first rule, to separate them from oxidation and reduction. Now, second one is to balance the atoms except oxygen. We now say this is carbon here. How many carbon is here? We have 2 carbons. How many carbon is here? We have 1 carbon. So to make it 2, I have to add 2 here to balance it. So I have 2 carbons there. Now come here. How many manganese here? We have 1. How many manganese here? We have 1. When I say how many manganese, I'm referring to the coefficient or a subscript. Like this carbon here is having a subscript of 2. So we have 2 carbons here. But manganese here is having 1. No number here. We assume it's 1. But here it is also 1. Don't take charge as the number of manganese. 2 plus is a charge. It is not the amount of manganese here. Now, that is the second one. You balance the atom except oxygen. The next one is to now balance oxygen. How do we balance oxygen? According to the rule that we read, you balance the oxygen by adding H2O to the side that is deficient of oxygen. Meaning, the side that have lower oxygen, we are going to add H2O. Now, look at this. How many oxygen do we have here? We have 4 oxygens. How many oxygen do we have here? We have 2 times 2, 4. Oxygen is balanced. Since oxygen is balanced, you cannot add H2O to it. Likewise, you cannot add H plus to it. What we are going to do now is, we now move on to balancing our charge. Now, we now check this place. In C2O42 minus, what is the charge in this compound? The charge is carrying here is -2. -2. The charge in this CO2, there's no charge on top here. We call it 0. Now, to now balance the charge, you add electron to the side that is having higher positive charge, meaning the side that is having higher positive charge. Now, -2 and 0, which one is more higher in positive charge? We have 0. So what are you going to take away from 0 to get this -2? You are going to remove -2 from 0 to get -2. It means we are going to add 2 electrons here. Don't forget, when I say 2 electrons, adding plus 2 electrons, this electron is negatively charged. Minus times plus, it should be minus. So which means 0 minus 2. That's what I'm going to have. So we are adding 2 electrons here. So here, I'm going to have C2O42 minus moving to 2 CO2 plus 2 electrons. I call this my equation 1. Fine. This is my equation 1. If you now look at this, the charge here is -2. The charge here is also -2. That is plus and minus. Then with this 2, -2. Now, move on to the second one. In this second one, we have, how many oxygen do we have here? We have 4 oxygen. But there is no oxygen here. To balance the oxygen, I'm going to add H2O to this side with no oxygen or with minimum oxygen. So there's no oxygen here, I had H2O here. So I have MnO4 minus moving to Mn2 plus H2O. Now, how many oxygen we have here? We have 4 and we have 1 here. To make this oxygen 4, I have to add 4 here. Now my oxygen has become 4, but something has changed. What is that? The number of hydrogen here. We have hydrogen here, 4 times 2, 8, and there is no hydrogen here. So we are going to add H plus to the side that is deficient of hydrogen or that have no hydrogen. So I'm going to add H plus here. So I have plus H plus. Now how many H plus am I going to add? 4 times 2, I have 8. So I'm going to add 8 here. Now, let's now look at this. I have balanced my oxygen. Oxygen here is 4, oxygen here is 4. Hydrogen here is 8, hydrogen here is 8. The next thing to balance is to balance my charge. What is the charge here? The total charge here, we have minus 1, minus 1. The charge here is this plus 8. So we are going to multiply this coefficient with the charge. 8 times 1, so we have plus 8. So minus 1 plus 8, we have plus 7. Total charge at the left hand side is plus 7. Come to the right hand side. Total charge here is plus 2, but I don't have charge here. That is 0, plus 0. So plus 2 plus 0 is plus 2. Now, to balance the charge, we are going to add a letter to the side that have more positive charge. Out of plus 7 and plus 2, which one is higher? Plus 7 is higher. We now say, what are we going to subtract from plus 7 to get plus 2? That what can you remove from plus 7 to get plus 2? Definitely 5. Meaning you are going to add 5 electrons to this side. So when we rewrite, we have MnO4 minus plus 8H plus 5 electrons to give us Mn2 plus 4 H2O. That is equation 2. Now, we've gotten equation 1 and equation 2. The next step now is to now balance the charge. If we look at equation 1, our charge here is 2. Equation 2, our charge here is 5. Then before we balance it, we have to know that oxidation and reduction means a process taking place at the same time. When you are balancing this, your charge, which is the electron, must not be on the same side. Look at this first equation. My electron is on the right hand side of the equation. That is at the product side. While here, my electron is at the reactant side. To now balance it, I can balance this one by multiply this equation by 5 to make this electron 10, while multiply this equation by 2 to make this electron 10. So, let's look at it. Okay, 5 times this, I'm going to have 5C2O4 2 minus to yield 5 times 2, 10 CO2 plus 5 times 2, 10 electrons. Now 2 times this, 2 MnO4 minus plus 2 times 8, 16 H plus 2 times 5 plus 10 electron to give us 2 times this, 2 Mn 2 plus 2 times 4, 8 H2O. So we have, now we have 10 electrons here, 10 electrons, so it's cancelled out. Then we combine the equation. This 5 C2O4 2 minus, there's no more charge, there's no more compound here. Move on to this, plus 2 MnO4 minus plus 16 H plus, so no more compound, to yield 10 CO2 plus 2 Mn 2 plus 8 H2O. Now, let us now check if this is balanced. We have 10 carbon here, 5 times 2, 10. then 10 carbons. Oxygen 5 times 4, 20. Oxygen here 2 times 4, 8. 20 plus 8, we have 28. Oxygen here 10 times 2, we have 20. Oxygen here is 8. 8 plus 20, 28. Manganese here we have 2. Manganese here we have 2. Hydrogen we have 16. Hydrogen here we have 8 times 2, 16. Balanced. Example 2. Balance the flowing redox reaction in acidic medium. Now, don't forget the first rule. We have to separate this into oxidation and reduction. So in this case, we have oxidation number. Now I want to look for the oxidation number of chromium here. Cr2O7, 2 minus. Oxidation number of chromium is what we are looking for. Let's call it an unknown, x multiplied by 2. It owns this 2 plus oxygen minus 2 times 7. Then it equals to the power here equals to minus 2. X times 2x, 2x plus and minus 2 times 7 we have 14 equals to minus 2. 2s is equals to, take this here, minus 2 plus 14. 2x is equals to plus 12. So if you have a side by 2, 2 cancel 2, s is equals to plus 6. So the oxidation number of chromium here is plus 6. What of carbon here? We've worked this one in the first example. So our carbon here is plus 3. Then chromium will equals to the power here, which is plus 3. Then carbon, we've done this one in the first example, plus 4. Now I want to separate this into oxidation and reduction. Chromium is moving from plus 6 to plus 3. That is, it's reducing. So it's reducing. So we have Cr2O7, 2 minus, to give Cr3 plus. We call it what? Reduction. Reduction. Then C2O4, 2 minus, is also moving to CO2. We call it oxidation. Oxidation. Fine. Now, the next step after differentiating this into oxidation and reduction, the next step is to balance the atoms except oxygen. Okay? How many chromium is here? We have 2 chromium and we have 1 chromium here. To balance this, we have to put 2 here. How many carbon is here? We have 2 carbons. Carbon here we have 1. To balance this, we have to put 2 here. So I've balanced the atom. Now the next step is to now look for the oxygen. Oxygen here we have 7 and there's no oxygen here. So we had H2O to the side, deficient of oxygen or having no oxygen. So we have Cr2O7, 2 minus, moving to 2Cr3 plus H2O. Now, how many oxygen we have here? We have 7 oxygen here. We are going to put 7 here to balance the oxygen. But as we balance the oxygen, something has changed. That is hydrogen. So hydrogen here is 14, and there's no hydrogen here. I will now add H plus to the side deficient of hydrogen. How many hydrogen? We are going to add 14 hydrogen. Now, adding 14 hydrogen to that side, I've balanced my oxygen and my hydrogen. The next step is to now balance my charge. Now, what is the charge here? Total charge here is minus 2. Total charge here is plus 14. Minus 2 plus 14, we have plus 12. Total charge here, it should be 2 times 3. We have plus 6. And charge here is 0. Now, here, I have plus 12 and plus 6. We are going to balance the charge by adding an electron to the side that is having more positive charge, that having higher positive charge, which is this plus 12. So we say, what can we remove? Since charge electron is negative, what can we remove from 12 to give us 6? Definitely 6. So I will add this electron to this place. So I have Cr2O7, 2 minus plus 14H plus 6 electrons to give 2Cr3 plus 7H2O. Let's call this equation 1. Now we move on to the next one, which is the oxidation part. We have two carbons here, we have two carbons here. It's balanced. We have four oxygen here, we have four oxygen here. Since the oxygen are balanced at both ends, so there's no need for us to add H2O. The next step is to balance the charge. What's the charge here? We have -2, and the charge here we have 0. Then we add electron to the side having more positive charge. So 0 is more positive than -2. So I'm going to add 2 electrons to that side. Here we are going to have C2O4 minus moving to 2CO2 plus 2 electrons. Equation 2. Fine. Now, my equation 1 is having 6 electrons. My equation 2 is having 2 electrons. To make them equal, I can multiply this equation 1 by 1 and equation 2 by 3. If I multiply this one by 3, I will definitely get 6 electrons. So let us move on. So 1 multiplied by this, I have Cr2O7 2 minus plus 14H plus 6 electron to give 2Cr3 plus 7H2O. Now 3 times this, we have 3C2O4 minus moving to 6CO2 plus 6 electrons. So we roll. At this junction, 6 electrons cancel 6 electrons. Then we combine the equations. The reactant together and the product. The reactant, we have Cr2O7 2 minus plus 14H plus, then plus 3 C2O4 2 minus to give 2 Cr3 plus 7H2O, then plus 6CO2. Let's check if it's balanced. We have 2 chromiums here. We have 2 chromium. 14 hydrogen. 7 times 2, 14. Carbon, 3 times 2, 6. Carbon, 6. Oxygen. Oxygen here is 7. Oxygen here, 3 times 4, 12. 12 plus 7, we have 19. Oxygen here, we have 7. Here, 6 times 2, we have 12, making 19. So this equation is balanced. We have come to the end of balancing of redox reactions in acidic medium. Before we meet in the next class to be discussing on how to balance in alkaline medium, kindly lay your hands on this simple exercise and try to follow the step by step which we have done in the previous examples. But before we move on, don't forget to subscribe if you are any member on this channel and click the notification bell for my subsequent contents. And do not forget to share, like, and comment for other learners for them to benefit in this channel. Thank you very much.